Every single year, we create over 50 million tons of electronic waste around the globe. That is a staggering mountain of old phones, laptops, and all sorts of gadgets. But what if the best solution to this massive high-tech problem wasn't some bigger, better machine, but something infinitely smaller? Let's dive into how the tiniest organisms on Earth could actually solve our biggest technological waste problem.
So, here's what we're going to cover. First, we'll look at the sheer scale of the e-waste problem. Then, we'll meet these incredible microscopic recyclers. After that, we'll break down exactly how they do what they do. We'll see why it's so much better than what we're doing now. And finally, we'll look at the incredible value they can pull out of what we thought was just junk.
All right, first things first, let's really dig into our towering e-waste problem. Because to really appreciate just how amazing this natural solution is, you first have to understand the size of the challenge we're facing.
So let me ask you a question, one that really affects all of us. Where do our dead electronics actually go? I mean, think about it. That old phone you've got stashed in a drawer, the laptop that finally died, where does all that stuff end up?
Well, the truth is, they all become part of this massive global mountain of high-tech trash. And this isn't your average garbage, not at all. It's this complex mass of really hazardous materials mixed right in with incredibly valuable metals. So you can think of it as both a toxic problem and a hidden treasure chest.
And that idea of treasure brings us to a really fascinating pivot. We've talked about the problem, so now let's talk about the solution. It's time to meet nature's tiniest recyclers.
When you're faced with a challenge this huge, you have to think differently. Scientists ask this brilliant question. What if the best tool for this job wasn't another loud, energy-guzzling machine? What if it was life itself? What if we could just get biology to do all the hard work for us?
And this brings us to the core science. It's called biohydrometallurgy. Okay, that's a mouthful, I know. But the idea behind it is actually beautiful and simple. We use living things, like bacteria and fungi, to basically eat our e-waste and spit out the valuable metals that are locked up inside.
So who are these little microscopic miners? Well, the main players in this whole operation are two of the oldest forms of life on Earth, bacteria and fungi. And these aren't some sci-fi genetically engineered superbugs. Nope. They are completely natural organisms that have evolved to process metals. We're just giving them a new place to work.
Okay, so we've got the problem, and we've got our tiny, living workforce. Now for the really cool part. Let's get into how biomining actually works. I mean, how in the world do you get a fungus to recycle a circuit board?
Well, it's not about just dumping microbes on a pile of junk and hoping for the best. Not at all. This is a super strategic, two-stage approach. It's designed to pull out different kinds of metals in a very specific and efficient order.
Think of it like a two-step biological dance. First, in step 1, you send in a team of acid-loving microbes. Their whole job is to go after the easy stuff, the base metals like copper. They produce acid that literally dissolves these metals right out of the crushed e-waste. Then, once they're done, step 2 begins. You bring in a different crew of microbes. These guys naturally produce just tiny, controlled amounts of cyanide, just enough to specifically target and release the really good stuff, like precious metals and rare earth elements. It's this perfect 1-2 punch delivered entirely by nature.
This all sounds absolutely incredible, right? But how does it really stack up against the old way of doing things? That's what this next section is all about. Greener, cheaper, cleaner.
So let's put these two methods head to head. On one side, you have traditional smelting. That means giant furnaces, burning things at incredibly high temperatures, which uses a massive amount of energy and pumps out toxic fumes. But biorecycling, it's eco-friendly, it's low energy. Smelting is super expensive and creates more toxic waste to deal with. This biological process, on the other hand, is cost-effective and creates almost zero waste. It is a clear win no matter how you look at it.
So we know it's greener, cheaper, and cleaner. But what do we actually get from all this? Let's move to our final section and see how this amazing process turns our waste into wealth.
And the payoff here it's huge. We're talking about recovering really high-value precious metals like palladium, critical rare earth elements like yttrium that our tech depends on, and of course common base metals like copper. We are literally turning our landfills into what you could call urban mines, pulling out resources that we'd otherwise have to dig out of the ground at a huge cost to our planet.
But wait, it gets even better. This is probably the most elegant part of the whole thing. What about the leftovers? The solid stuff that's left behind after the microbes are done.
Well, even that isn't waste. That residue can actually be used to create silicon nanomaterials, another valuable, high-tech product. It's a completely closed loop. Nothing, and I mean nothing, goes to waste.
So it leaves us with this pretty profound thought, doesn't it? We're always looking to the future for some bigger, faster, more powerful technology to solve our problems. But maybe the answer isn't just about building something new. Maybe it's about partnering with the oldest, most efficient systems on the entire planet. Could it be that nature's most ancient life forms are the real key to building a sustainable future for our technology?